Hello guys, welcome to my YouTube channel Best IT Solution, and this is a continuous series of my previous tutorial, that is a microservice related interview question and answer. So this is the part 3 of this interview question answer. So this is relevant for freshers and experience both. Okay, so today we'll discuss that question and answer series. So our first question is, what is service discovery and how it is helpful? Okay. So in a cloud environment where Docker images are dynamically deployed on any machine or IP address or port combination, it becomes difficult for dependent service to update at runtime. Okay, so what is service discovery and how it is helpful? So in our service discovery, how helpful in our application or project? So in a cloud environment, nowadays every projects are deployed in the cloud, that is AWS or Google App Engine, any cloud. So in a cloud environment where Docker images are dynamically deployed. So here in cloud environment we are creating the image of the applications, service microservices. So in cloud environment where Docker images are dynamically deployed on any machine or IP plus port, this is the IP address plus this is the port. Suppose the localhost colon the port is 8080. So this is the combination of this IP address and port. So it is very difficult to find the individual services in the cloud environment, and which service depends upon which service, that is also very difficult to find. So service discovery is created due to that purpose only. So service discovery help to find that service individually. It is very helpful. So service discovery is one of the services running under microservices architecture, which registers entries of all of the services running under the service mesh. Service mesh means that is group of service. So service discovery is one of the, it is also service, but if all other services are there registered under these services. So by which we can easily find out the other services with the help of this service discovery. So all of the actions are available through the REST API. So whenever the services are up and running, the individual service registers themselves to service discovery service, and service discovery services maintains heartbeat to make sure that those services are alive. So service discovery it is the responsibility of service discovery which service is alive. So it maintains the heartbeat to make sure that these services are alive till now. So that also serves the purpose of monitoring services as well. So that also serves the purpose of monitoring of services as well. Service discovery also helps in distributing requests across services deployed in a fair manner. So suppose there are 10, 20 services are there. So it is the responsibility of service discovery also to distribute this request across the service deployed in the fair manner. Okay, so this is the whole about the service discovery. So our second question is, how do microservices communicate with each other? So how the microservices are communicate with each other? So generally, microservices are often integrated using a simple protocol like REST or over HTTP. Microservices are often integrated using a simple protocol like REST over the HTTP, hypertext transfer protocol. Other communication protocols can also be used for integration like AMQP, JMS, Kafka. So these are also the protocols for integration. So other communication protocols can also be used for integration like AMQ, JMS, but mostly microservices are integrated with the protocols REST over the HTTP. The communication protocol can be broadly divided into two categories. So generally the communication protocols, how the microservices communicated with each other, are broadly divided into two categories. One is asynchronous communication and another is synchronous communication. So we'll see one by one what is asynchronous communication and what is synchronous communication. So first one is asynchronous communication. So in this type of communication, the client does not wait for a response. So in asynchronous communication, the client does not wait for a response. Instead, it just sends the message to the message broker. So instead of waiting, it just sends the message to the message broker. AMQP like RabbitMQ. So AMQP also tools like the RabbitMQ. So AMQP or Kafka can be used for asynchronous communication for message passing. across microservices to achieve essential consistency. Okay, so the AMQP or the Kafka can be used for asynchronous communication across the microservices to achieve this as even eventual consistency. To achieve the eventual consistency, AMQP or the Kafka can be used. So this is asynchronous communication. So another one is synchronous communication. So mostly we are using the synchronous communication. In asynchronous communications, the services does not wait for the response. But in synchronous communication, REST template, web client, fin client can be used for the synchronous communication between two microservices. Okay, so the between the communication between two microservices in synchronous communication manner, we are using the REST template, web client, fin client. Okay, so these tools helps to communicate between the service. Ideally, we should minimize the number of synchronous calls between microservices because networks are brittle and they introduce latency. So generally, we should minimize the number of synchronous communication. Generally, we are minimize the number of synchronous calls between the microservices because if there are more number of synchronous calls, it networks are brittle or they introduce the latency. So Ribbon is a client-side load balancer. Ribbon is a client-side load balancer can be used for better utilization of resource on the top of the REST template. So Ribbon is a client-side load balancer can be used for better utilization of the resource on the top of REST template. And another one is strict circuit breaker. Strict circuit breaker can be used to handle partial failure gracefully without a cascading effect on the entire ecosystem. Okay, so strict circuit breaker can be used to handle partial failures gracefully without the cascading effect on the entire ecosystem. Suppose there is a one service is called try to call another service and that service is now not available, then this strict circuit breaker is very much helpful to handle the partial failure of the services. Distributed commits should be avoided at any cost. Instead, we shall optimize for eventual consistency using asynchronous communication. So, distributed commits should be avoided at any cost. Instead, we shall optimize for eventual consistency using the asynchronous communication. Okay. So, our third question is how will we develop microservice using Java? So, in Java, how can we develop the microservices? So there are very useful tools that is Spring Boot. So Spring Boot along with Spring Cloud is a very good option to start building microservices using Java language. So Spring Boot along with the Spring Cloud is a very good option to start with the building microservices using Java language. There are a lot of modules available in Spring Cloud that can provide boilerplate code for different design patterns of microservices. So Spring Cloud can really speed up the development process. Okay. So there are a lot of modules. So there are a lot of module available in the Spring Cloud, and we are by using this module, we are using the we can easily develop the microservices, and the development process can be faster. Also, Spring Boot provides out the box support to embedded a servlet container. So, Spring Boot contains an embedded container for the server. So, inside the Spring Boot, there are Tomcat or JT or under to insert the executable jar, so that these jars can be run directly from the command line, eliminating the need of the deploying WAR files into the servlet container. So, we need not the external server for the deploying the services. So there is inbuilt Tomcat is there. So you can also use Docker container to ship and deploy the entire executable package onto a cloud environment. So you can also use the Docker container to ship and deploy the entire executable package onto a cloud environment. So Docker can also help eliminate works on my machine problems by providing logical separation for the runtime environment during the development phase. So Docker also helps to eliminating the reducing the works on from my machine problem by providing logical separation for the runtime environment during the development process. That way you can gain portability across on premises and cloud environment. So in this way you can gain portability across on-premises and cloud environment. So another question is, what is a good tool for documenting microservices? So Swagger is a very good open source tool for documenting APIs provided by the microservices. So Swagger is a very good open source tool for documenting the microservices. It provides very easy to use interactive documentation. By the use of Swagger annotation on REST endpoint, API documentation can be auto-generated and exposed over the web interface. Okay, so by using this Swagger annotation, the REST point endpoint can be easily documented and can auto-generated and exposed over the web interface. An internal and external team can use web interface to see the list of APIs and their input and the error code. So there is the internal external team are there. So internal and external team can use web interface, whatever the web interface, they can use the web interface to see the list of APIs and their inputs and error codes. They can even invoke the endpoints directly from the web interface to get the results. Okay, so they can invoke the endpoint directly from the web interface to get the results. Swagger UI is a very powerful tool for your microservices consumers to help them understand the set of endpoints provided by a given microservice. So the Swagger UI is a very powerful tool for your microservice consumers to help them understand the set of endpoints provided by the given microservice. Our next question is how to handle versioning of microservices. So how we can handle the versioning? So there are different ways to handle the versioning of your REST API to allow older consumers to still consume the older endpoints. The ideal practice is that any no background compatibility change in a given REST endpoint shall lead to a new version endpoint. So different mechanisms of versioning are, so we can in different we can manage the versioning, like add version in the URL itself, add version in API request header. So we can add the versioning in URL itself directly, or you can we can add the versioning in the API request header also. So most common approach in versioning is the URL versioning itself. So indirectly in URL we are adding the version itself. A version URL looks like the following. So if we are adding the version in URL, the URL look like this, like HTTP host port and the API slash version. That means this is the version 1. And HTTP host port API, this is the version 2. So in this way, in the URL we can add the versioning in the URL. As an API developer, you must ensure that only backward compatible changes are accommodated in a single version of URL. Consumer driven test can help identify potential issues with API upgrades at the earliest stage. Okay, so as a developer, you must ensure that only backward compatible changes are accommodated in a single version of URL. Okay, so consumer driven test, there are tests are there, consumer driven test. In consumer driven test can help identify these potential issues with the API upgraded and the early stages. So what are the new version released or not, that the consumer driven test can help to identify these changes. Another question is, on what basis should microservices be defined? On what basis should microservices be defined? So it is a very subjective question. Okay, so but with the best of my knowledge, I can say that it should be based on the following criteria. So I have mentioned some criteria, so it should be based on this following criteria, like business functionalities that change together in bounded context, service should be testable independently, and changes can be done without affecting clients as well as the dependent services. So changes can be done without affecting the dependent services and the client. It should be small enough that can be maintained by 2 to 5 developers. Reusability of a service, we can reuse usable. So these are the you can say these are the characteristics of the microservices. So here are the characteristics of microservice architecture. Another question is characteristics of a microservice architecture. So characteristics like high cohesion. So small and focused on doing one thing well. Small does not mean less number of lines of codes, because Few programming languages are more verbose than others, but it means the smallest functional area that a single microservice caters to. So this is the high question, that is the small and focused on doing the small thing. That means the programming languages are very small. Small does not mean less number of lines of code, but few programming languages are more verbose than others, but it means the smallest functional area. So each functional area has the services. So smallest means this is a smallest functional area of a service covered. And the loose coupling means autonomous, the ability to deploy different services independently. So different services we can deploy independently. That means one service and not depend upon the other service. So this is the loose coupling. And reliability, due to ability for a service to run even in if another service is down. So one service also will run if another service is down. Another is bounded context. So a microservice serves a bounded context in a domain. It communicates with the rest of the domain by using an interface for that bounded context. Okay, so a microservice serves a bounded context in a domain. It communicates with the rest of the domain by using an interface for that bounded context. Another characteristic is like organization around business capabilities instead of around technology. So organization are mainly focused on the business capabilities. Continuous delivery and infrastructure automation. So we can continuously deliver the development and infrastructure automation. Versioning for backward compatibility. Even multiple versions of same microservices can exist in a production environment. Another characteristics like fault tolerance. If one service fails, it will not affect the rest of the system. For example, if a microservice serving the comments and reviews for e-commerce fails, the rest of the website should run fine. Okay, so suppose there is a comments service are down, then the rest of the services will run fine. So more characteristics like decentralized data management, with each service owning its database rather than a single shared database. So decentralized data management, with each service owning its database rather than a single shared database. So that means if there are individual services there, individual service can use the individual data. For example, every microservice has the freedom to choose the right type of database appropriate for its business use case. For example, RDBMS for order management and NoSQL for the catalog management can use for an e-commerce website. Okay, for an e-commerce website, suppose there are two services, one is order management, another is catalog management. So the catalog management can use the NoSQL database, and the order management can use the any RDBMS or any Oracle, any MySQL, any relational database. Okay, that means each microservice can choose their own database. Another is eventual consistency. That means event driven asynchronous updates. Security. So every microservice should have the capability to protect its own resources from unauthorized access. So this is the main functionality. Like each services should have the capability to protect their own resource from the unauthorized access. This is achieved using stateless security mechanism like JSON Web Token, that is JWT token. So we can achieve this security by different way. So by using the JSON Web Token, also we can use the JSON Web Token with OAuth 2 security, also open authorization. Another question is what is bounded context? So bounded context is a central pattern in domain driven design, DDD. So in DDD, domain driven design, bounded context is a central pattern. In bounded context, everything related to the domain is visible within context internally, but opaque to other bounded context. DDD deals with large models by dividing them into different bounded contexts and being explicit about their interrelationships. Monolithic conceptual model problem. So what are the monolithic conceptual model problem? Like a single conceptual model for the entire organization is very tricky to deal with. So a single in monolithic concept, a single conceptual model for the entire organization is very tricky to deal with. The only benefit of such a unified model is that integration is easy across the whole enterprise. So, in the advantage of the monolithic application is the integration is easy across the whole enterprise, but the drawbacks are many. But there are many drawbacks of these monolithic applications, like drawbacks like at first it's very hard to build a single model that works for the entire organization. For the first thing, it is very difficult to build a large application single model that works for the entire organizations. It's hard for others teams to understand it. So to understand the other team members, it is very difficult because the project is very huge. It's very difficult to change such a shared model to accommodate the new business requirement. The impact of such a change will be widespread across team boundaries. Okay, so if we want to make a change in particular module, it is very difficult to change because these are the tightly coupled with the other modules. Any large enterprise needs model that is either very large or abstract. So meaning of a single word may be different in different departments of an organization. So it may be really difficult to come up with a single unified model. Such a model, even if created, will lead to a lot of confusion across the teams. So another question is, what would be your logging strategy in a microservice architecture? So logging is a very important aspect of any application. So logging is a very important aspect of any application. If we have done proper logging in an application, it becomes easy to support other aspects of the application as well. Like in order to debug the issues, in order to understand what business logic might have been executed, it becomes very critical to log important details. So through the logs only we can monitor the application flow. So ideally you should follow the following practices for logging. Okay, so in microservice architecture, each request should have a unique value, and this value should be passed to each and every microservice so the correlational can be logged across the services. So in microservice architecture, each request should have a unique value, that is correlation ID, that unique value, and these values should be passed, and this correlation at this unique value should be passed to each and every microservice so the correlation ID can be logged across the services. So thus the request can be traced with the help of this unique value, that is correlation ID. Logs generated by all the services should be aggregated in a single location so that while searching becomes easier. So the whatever logs are come, that will be generated and aggregated in a single location by which we can easily searching the logs. Generally, people use the ELK. ELK means Elasticsearch, Logstash, and the Kibana stack for the same. So generally, to monitor the log of a application, people use the ELK stack for the same, so that it becomes easy for support persons to debug the issue. So with the help of the ELK, Elasticsearch, Logstash, and Kibana dashboard, it is easy to trace the log. What are the tools and libraries available for testing microservices? So important tools and libraries for testing Spring based microservices are, so there are different tools and are there, like JUnit. So JUnit used to for the standard runner. So the standard test runners, it's called JUnit. TestNG, the next generation test runners, and the Hemcrest, that is the declarative matches and declarative matchers and assertions. So this is also a special type of test for the declarative matchers and assertions. REST assured for writing REST API driven and to end-to-end test. Okay, so REST assured is used for writing REST API driven end-to-end tests. So more tests are like Mockito for mocking the dependencies, and WhereMock for stopping third-party services, and the Hoverfly create API simulation for end-to-end tests. So this Hoverfly use the create API simulation end-to-end test. Another one is Spring Test and Spring Boot Test for writing Spring integration test, includes mock MVC, test REST template, web client like features. With the help of these features, we can use the Spring Test or Spring Boot Test. So more tests are like JSON assert, an assertion library for JSON, and Pact. The Pact family of frameworks provides support for consumer-driven contract testing. Okay, so Selenium automates browsers. It's used for end-to-end automated UI testing. Selenium is for end-to-end automated testing. Gradle helps build, automate, and delivery software faster. So Gradle, Maven, these are the build tool for the automate and deliver the software faster. IntelliJ IDEA, this is a IDE for Java development. So IntelliJ IDEA and the Eclipse, NetBeans, and the STS Spring Tool Suite, these are the IDE for the Java development. So Spring, using how we can use the Spring Boot starter test. So we need to just add the dependency for the Spring Boot test, that is in our builder Gradle or the in Maven pom.xml. So if we are using the Gradle, we should add this dependency in build.gradle, and if we will use the Maven as a build tool, then we should add the dependency in pom.xml file. So the dependency is test compiler org.spring framework.boot Spring Boot starter test. So Spring Boot starter test, this is the dependency. This starter will import two Spring Boot test modules, Spring Boot test and Spring Boot test autoconfigure, as well as JUnit, assert J, hammer test, Mockito, JSON assert, Spring test, Spring Boot test, and a number of other useful libraries. So okay, so these dependency I will provide all this type of tests. What is ubiquitous language? So if you have to define the ubiquitous language UL, then it is a common language used by developers and users of a specific domain through which the domain can be explained easily. So by the help of this ubiquitous language, a domain can be explained easily to developers and the users. The ubiquitous language has to be crystal clear so that it brings all the team members on the same page and also translates in such a way that a machine can understand. So the ubiquitous language has to be crystal clear so that it brings all the team members on the same page and also translate in such a way that a machine can understand. Okay. So this is the ubiquitous language. What problems are solved by the Spring Cloud? So while developing distributed microservices with the Spring Boot, we face few issues which are solved by the Spring Cloud. So while developing the distributed microservices in Spring Boot, we face a lot of issues which are solved by the Spring Cloud. So some issues are like the complexity associated with distributed system. So these includes network issues, latency overhead, bandwidth issues, and the security issues. So any one of issues can be maybe arise, and these are resolved by the Spring Cloud. Ability to handle service discovery. So service discovery allows processes and services in a cluster to find each other and the communicate with each other. Another issue like solved redundancy issue. So redundancy issues often occur in distributed systems. So it is a common issue which are often occur in the distributed system. Load balancing improves the distribution of workloads across multiple computing resources such as a computer cluster, network links, central processing units. Okay, so this is the load balancing improves the distribution of workloads across multiple computing resources such as a computer cluster, network links, central processing units. Another one issue like reduces performance issues. Reduces performance issues due to various operations overheads. Another question is, can you give a gist about the REST and the microservice? So what is the REST and what is microservice? REST. Through REST you can implement microservices in multiple ways. REST over HTTP is a way to implement the microservice. REST is also used in other applications such as web apps, API design, and MVC applications to serve business data. Microservice is an architecture wherein all the components of the system are put into individual components which can be built, deployed, and scaled individually. So with the help of this REST, we can build out the microservice. So there are certain principles and best practice of microservices that help in building a resilient applications. Okay, so there are some principles and best practices there to develop a building a resilient microservice. So microservice is an architectural wherein all the components of the system are put into individual components which can be built, deployed and scaled individually. In a nutshell, you can say that REST is a medium to build microservice. In a nutshell, you can say that REST is a medium to build microservice. What is a consumer driven contract, CDC? So this is a basically a pattern for developing microservice so that they can be used by external system. So CDC is a pattern for developing microservices by which the external systems can easily use this microservice. When we work on microservices, there is a particular provider who builds it and there are one more consumers who use microservices. So in microservice architecture, there is a particular providers who builds it and there are one or more consumers who use the microservices. Generally, providers specify the interfaces in an XML document, but in consumer-driven contract, each consumer of service conveys the interface expected from the provider. But the consumer-driven contract, each consumer of service conveys the interface expected from the provider. What is dry in microservice architecture? So dry stands for don't repeat yourself. So to remove the boilerplate code, this can be used like dry don't repeat yourself. So it basically promotes the concept of reusing the code. So we can reusing the code by itself. Don't write the code again and again same code. So this results in developing and sharing the libraries, which in turn result in tight coupling. How can we perform cross-functional testing? So the cross-functional testing is a verification of non-functional requirements. So this is a verification of the non-functional requirements. So those, for example, that is those requirements which cannot be implemented like a normal feature. So those requirements which cannot be implemented like a normal features. What is the role of web RESTful APIs in microservices? So a microservice architecture is based on a concept wherein all its services should be able to interact with each other to build a business functionality. So to achieve this, each microservice must have an interface. This makes the web API a very important enabler of microservice. Being based on the open networking principles of the web, RESTful API provided the most logical model for building the interfaces between the various components of Microservice architecture. So in Microservice architecture, RESTful API provide a most logical model for building the interfaces between the various components. How can we eradicate non-determinism in tests? So non-deterministic tests (NDT) are basically unreliable tests. So sometimes it may happen that they pass and obviously sometimes they may also fail. As and when they fail, they are made to rerun to pass. Some ways to remove non-determinism from test from our code are as follows. So there are some ways to remove this non-deterministic from our code, that is quarantine, asynchronous, remote service, isolation, time and resource leaks. So these are the some ways to remove the non-deterministic tests. What is the difference between mock or stop? So stop, a dummy object that helps in running the test. So the stop is a dummy object which helps to running the test. Provide fixed behavior under certain conditions which can be hard coded. So it provides the stop provides a fixed behavior which are under certain conditions which can be hard coded. Any other behavior of the stub is never tested. Any other behavior of the stub is never tested. For example, for an empty stack, you can create a stub that just returns true for empty method. So this does not care whether there is an element in the stack or not. So if we are hard coded the value, but each time when you are calling the empty method, it will return the true. So if whether the stack is empty or not, that is not the determined by the that stop. And mock, a dummy object in which certain properties are set initially. In the mock object, certain properties are set initially. The behavior of this object depends on the set properties. Okay, so the behavior of this mock object depends on the set properties. The object's behavior can also be tested. In mock, the object behavior can also be tested. For example, for a customer object, you can mock it by setting name and age. You can set age as 12 and then test for is adult method. That will return true for age greater than the 18. So your mock customer object works for the specified conditions. What is the role of an architecture in microservice architecture? What is the role of an architect in a microservice architecture? Okay. So you need to understand the question properly. So an architect in microservice architecture plays the following roles: decides brand strokes about the layout of the overall software system. So it decides the broad strokes about the layout of the overall software system. Helps in deciding the zoning of the components. So they make sure components are mutually cohesive but not tightly coupled. Code with developers and learn the challenges faced in day-to-day life. Make recommendations for certain tools and technologies to team developing microservices. Provide technical governance so that the team in their technical development follow principles of microservice. Okay, so these are the main role of the architect in the microservice architecture. Can we create state machines out of microservice? As we know that each microservice owning its own database is an independently deployable program unit. This in turn let us create a state machine out of it. So we can specify different states and events for a particular microservice. For example, we can define an order microservice. An order can have different states. The transitions of order status can be independent events in the order microservice. Okay, so we can, that means can we create a state machine out of microservice? Yes, we can create the state machines out of the microservices. What are the 3 C's of microservices? So the 3 C's of microservices refer to the 3 essential principles or characteristics that are often associated with microservice architecture. So these principles help guide the design and development of microservice based applications to ensure their effectiveness and success. Okay, so the 3 C's of microservices refer to the 3 essential principles or characteristics that are often associated with the microservice architecture. So these 3 C's principle help to guide the design and the development of microservice based applications. And it ensures the effectiveness of the success. The 3 C's are componentization, communication and the containerization. Okay, the componentization, communication and the containerization. So what is componentization? So this concept says that a monolithic program should be broken up into smaller parts called the microservice that can be deployed and managed on their own. So in componentization, this concept says that a monolithic program, a big application should be broken into a smaller parts called microservices and that can be deployed and managed individually. Each microservice is in charge of a certain business capability or function which gives the teams the freedom to build, test and launch them on their own. Componentization encourages a modular and independent architecture which makes the programs easier to manage and grow. Okay, so the componentization encourages a modular and independent architecture which makes the program easier to manage and grow. Another C is like communications. So in a microservice design, it's important for service to talk to each other so that the whole system works well. So communication is very important vital role. Service talk with each other through well-defined APIs which often use lightweight protocols like HTTP REST or message systems like Kafka or RabbitMQ. So communication patterns must be designed in a way that it allows free linking and flexibility so that services can change on their own without affecting the whole system. So containerization. Containerization is the process of putting apps and things they need into separate containers like Docker containers. So containerization means it is a process to putting the apps and the services in a particular container like Docker container. Containers provide a consistent and portability setting that makes sure microservices run the same way on different devices and environments. So container provides the consistent and portability setting and ensure that the microservices run the same way on different devices and the different environments. Containerization makes it easy to launch, scale and handle microservices. Okay, so the containerization makes it easy to launch the service, to scale the microservice and to handle the microservices. For this reason, it is a core part of many microservice architecture. So, the containerization is the core part of the many microservice architecture. On note is there like these three C's: componentization, communication and containerization help organizations adopt a microservice architecture successfully. Okay, so if one organization follows these three C's properly, it will bring the successfully of the microservice architecture. It will make a successful of microservice architecture deployment. So they promote flexibility, scalability and maintainability, allowing development teams to build complex and distributed applications that can evolve and adapt to changing business needs efficiently. Okay. Okay, so this is the main role of these three C's. What is canary releasing? So canary releasing is a technique to reduce the risk of the introducing a new software version in production. So in this canary releasing, what we will do, this is done by slowly rolling out the change to a small subset of the users before giving it out the entire infrastructure, that is making it available to everybody. So if we have make a simple change to the applications, instead of giving it directly to the production to the whole customers, we will just slowly rolling out these changes to a small subset of the users before giving out the entire infrastructure. Okay, this is the canary releasing. What is the purpose of Docker? So the Docker provides a container environment that can be used to host any application. So Docker provides a container environment which can be used to host any application. So in this software application and their dependencies which support it are tightly packaged together. So the application and its dependency are tightly packaged together in the container, Docker container. So this packaged product is called the container, and since it is done by the Docker, it is also called as the Docker container. How can we perform cross-functional testing? So cross-functional testing is a verification of non-functional requirements, that is those requirements which cannot be implemented like a normal feature. So the cross-functional testing is a verification of non-functional requirements, that is those requirements which cannot be implemented like a normal feature. Okay, so this is the cross-functional testing. Okay. So this is the last questions of this tutorial. So we explain the microservice architecture diagram. I will create a different individual video for this explaining the microservice architecture. Here just simply I am explaining it like so. First the user request comes to the API gateway. It hits the API gateway and it is the responsible of API gateway to routes the request for a particular microservice. Suppose there are two microservices, there are user and another is department. So the API gateway decides the request is for the which microservice, and according to that it will redirect to the request to the user microservice, and also if it is for the department, it will redirect to request to the department microservice. Okay, and with and another there is strict dashboard for the circuit breaker. So if there is one, suppose the user service is searching for the data in department service and if department service is failed, so it will automatically call the fallback method of the strict dashboard or circuit breaker. And all these API and strict dashboard, circuit breaker and the department, all the services are registered in the service registry. Okay, this is the we are using the Eureka server for the service registry. So this is the service registry and these are the client. This is the Eureka. This API gateway, stick dashboard, user. These are the Eureka. This is the Eureka client, and the whole this is the registered in the service registry. This is the Eureka server. And another thing is the config server. So there are some common configurations are there. Suppose there are 10, 20, 30, 100 microservices are there. So to if one modifications are made, we need to change all the microservices. So instead of that, if we the common configurations we are placing in one place, and we are fetching in that configuration from that place directly, all if we change in that one place, it will reflect to all the microservices. So for that we are using the config server, and it will this config server, it is also a microservice. It will fetch the common configuration from the Git. Suppose in a Git repository we have stored all our common configurations, and the config server fetched all that common configuration from the Git, and it will provide to all the services inside the service registry. And another thing is Zipkin server. So there are for the log tracing in distributed system, there are tools used like Zipkin and Sleuth. So the Zipkin and Sleuth are used for the log tracing. Whatever service is down, or how the requests are flow from one service to another service to another service, which service in which service the our request has stopped running. So all these are traced from the Zipkin dashboard. So in Zipkin dashboard, we can trace with the help of this trace ID or the span ID are there. With the help of this trace ID, span ID, we are tracing the log in the distributed environment. Okay. So this is a overall architecture of the diagram, a Microservice architecture. Okay. Okay, so this much in this video tutorial. So thank you guys, and if you think that you have got some knowledge, please like and share the video, and please subscribe the channel, by which I can motivate and I can make more and more video regarding this topic. I will also try to make the practical of video of this microservice tutorial. Okay, so thanks for watching.